How are we doing, everyone? Mr. Honig here. I'm going to be walking you guys through how to simplify radicals and then combine these radicals if necessary. So first thing we have to do is we see a set here of radicals, and what we should already know is if we have something like root 2 plus root 3, we should already know that we cannot simplify this any further. This is similar to just saying we have 2x plus 3y. Okay, so because we have different coefficients here, we can't combine these two together. Where the same thing is true here, just like a coefficient, just like an x and a y, we can't combine root 2 and root 3 because they are not the exact same radical. So we actually have to leave them apart. We have to leave it as root 2 plus root 3. Now, conversely, if they were the same radical, so let's say this was 4 root 3 plus root 3, then I could combine them. I'm going to write this in. This is a 1 root 3 in case we forgot. And then I could just combine the coefficients. So I'm just adding 4 plus 1, which is 5. And then I'm leaving the root 3 just as if it was a 4x plus 1x. We would keep the variable the same, and then we would just add the coefficients. So that's what we want to get down to. We want to simplify all the way down to when the radical is as simplified as possible, and then combine any like terms if it is necessary. Okay, so I have a couple of radicals up here. So I'm taking 2 root 45 minus root 80, and then I'm adding 6 root 343 to it. Now, the first thing we should do, this could be our final answer, but we should try to simplify our radicals as much as possible. Okay, so as we recall, we're going to leave this 2 on the outside here, and we're going to split that root 45. So that root 45 actually splits into 9 times 5, okay? And we know that this 9 is the largest perfect square. That's a factor of 45. Minus root 80. The largest factor that is a perfect square of 80 is 16, and it's 16 times 5. So again, there's my perfect square. I'm going to circle that guy, all right? Plus 6 root. The largest perfect square in here is actually 49, and it's actually 49 times 7, okay? So I've circled all my perfect squares, and now we're just going to simplify as we have before, okay? So I'm going to pull out the square root of 9 here. I'm going to leave this as 2 times the square root of 9, which is 3, and then what's left underneath the radical is this 5. Minus, there's nothing really out here to simplify other than the square root of 16, which is 4 root 5. And then plus 6 times the square root of 49 is 7. And there's a root 7 left underneath. Okay. So now all I have to do is multiply here first. We have to multiply following order of operations. We have to multiply before we add or subtract. 2 times 3 is 6. So I have a 6 root 5. Nothing to multiply here, minus 4 root 5, and then 6 times 7 is 42, so 42 root 7. And now we just have to figure out, do we have any like radicals? Do we have the identical radical, identical number or terms underneath the radical? I see root 5 and root 5. Those are identical, so these are my like terms, okay? So I'm going to just simply add or subtract with the coefficients. In this case, because signs are different, I'm going to subtract. 6 minus 4 is 2, and I leave the root 5. And because this one did not have a like radical, I can't really add it to it other than leaving it as its expression, 42 root 7. And that's your final solution.